In this video, we'll take a look at how to use blueprints with custom attributes in PCG. First, we'll start off with a brand new scene, and we'll want to go to Edit, Plugins, and make sure that we have our Geometry Script plugin loaded, as well as our PCG, Procedural Content Generation Framework plugin loaded. Next, I'll import a model which you can find on the Patreon, which we'll use to scatter with PCG to make more complex structures. One thing to keep in mind is if you make your own model or you import a model and the normals look strange in Unreal and they don't look correct, check to make sure that when you import that model, that on the Unreal import options, you've turned off recompute normals. Sometimes Unreal will recompute all the normals and erase or remove your normal flat or smooth shading. Next, what I'm going to do is create a new blueprint, and I'll make this blueprint just a simple actor blueprint. And for now, I'll give it some sort of name. Maybe for now, I'll just call it something like BP underscore greeble, and I'll open it up. And once I open up this blueprint, we're going to add a component, which is going to be a static mesh. And that's going to be the mesh that we're going to kind of scatter or duplicate to make more complex structures. And what we're doing here is we're showing how you can use blueprints along with PCG and custom attributes to get the best from both worlds. So you're not just stuck with PCG, you're not stuck with just blueprints. You can actually use PCG to scatter blueprints and change the blueprint variables or settings. Now, once we have our static mesh added, we're just going to go and select our geometry that we want. And there is our geometry that we're going to scatter. And the next thing that we want to do is make this into a more complex structure. You could technically make this shape totally procedural, which would be a little bit more advanced. Some of my other videos have examples going over how you can use construction script to make totally procedural buildings. But in this case, we're just going to use this pre-made or just simplified model. But what we are going to do with it is scatter it around another shape. So the next thing I'm going to do is go to the construction script here at the top, and I'll give myself a little bit more room. And inside this construction script, what I'm going to do is take that static mesh that we have, and I'm going to drag it into here. So I'm going to get it. And from that static mesh, I'm going to get the bounds of it. So the bounding box of it. So what I can do is drag that out and do something like a get bounding box. And if we don't see anything showing up, we can turn off context sensitive. And then we get this option that says get mesh bounding box or static mesh get bounding box. And when I select that, you'll see that it kind of does this little conversion to a static mesh, or connects up our static mesh to the target, and then gets our bounding box from that. And this is going to return some values. And it returns it right now as a structure, but we can right click and split that. And now we have the minimum and maximum size of that bounding box. So now we can use those minimum maximum sizes to determine where to scatter duplicates of this mesh at different sizes or different rotations. Now, one thing that we want to do is we want to scatter this piece, but we don't want it to always scatter the same way. We want some random seed changing how it scatters every time. And maybe we want a seed number to be able to change that scattering, a number where if we change that number, it changes how it scatters the duplicates of this object along itself. And to do that, to not have it totally random, but to have it based on a seed number, we're going to have to create a node called set random stream seed. And what it's going to do is allow us to have a seed number and create scattering based on that seed. So if we enter a certain number, it always scatters a certain way. But if we change that number, it scatters a different way. Now, to use this, I first have to connect this up to a stream here. So I have to actually go into my blueprint here, into the variables, and add a new variable. I'm just going to call it stream seed, and I'll change its type to a random stream. and I'll drag that into here and connect that up. So something like that. And if I do that, then all we need to do is have our seed number here. And to use this or to properly see this in action, we'll have to start scattering our object along itself. So maybe after this, I'm just going to do a for loop. So I'll do something like a flow control for loop, and that will loop a bunch of nodes or redo a bunch of steps a number of times from starting point to the ending point. And maybe I'll just scatter 10 boxes or 10 of these same geometries along itself. And to do that, so it's going to start the construction script. It's going to set up our seed and then do our loop 10 times. Each time it does that loop, we're going to add a static mesh component, which will be our mesh. So what is our mesh going to be? Well, we can go in here, we can select it from our static mesh, or we can kind of connect it up to here. But probably the easiest would just be to go in here and select our mesh. So I have my mesh selected. Now, right now, it might be hard to tell if this does work because it will probably just place 10 of these geometries right on top of each other. So what we're going to do instead is also add a transform. So we're going to do a set relative transform. So we're going to move the cube or the geo or whatever we're creating every single time. And we have to make sure this is the right node. It'll be set relative transform, but we want to make sure context sensitive is on, and it's for static meshes. And it will give us a target connection, but we can delete that and just connect it up to this mesh that it just created. And now it's creating that mesh 10 times and then adding a transform. So next thing we have to do is set up that transform. So I'm going to take this transform, split it so we can see the X, Y, and Z location, rotation, and scale. For now, we'll just worry about the location. So we'll split that. And now we got each individual direction or position, the X, Y, and Z position as individual connections. And we can take our get mesh bounding box or get our bounding box of our mesh and do the same thing, split the minimum, the maximum, and we can use our seed to vary which location we pick within this min and max values. So what I'll do is I'll take this stream seed, I'll drag it out and do a random float in range. So from a minimum and maximum range, a random number within that range from this seed stream. And I'll set the minimum to our minimum bounding box, our maximum to a maximum bounding box for X. And then the output will be our X position. And we'll do this. I'll just copy and paste this for X, Y, and Z. You could probably simplify this into less nodes, but I'm just doing this so we can see how this is pretty much randomizing each axis, X, Y, and Z, and getting us a random value from the minimum size of the bounding box to the maximum size of the bounding box, and then using that new location to place our duplicate of our mesh. And after doing that, maybe what we also want to do is randomize the rotation or the scale, but let's first check to see if this works now. So upon clicking compile and going to our viewport, there it is. It's placing a bunch of these boxes within the bounding box randomly of its original size. So it's kind of like offsetting them randomly and placing them. So that kind of works, but having a random scale and random rotation might make that look a little bit better. So perhaps that's the next thing we want to do. So random scale will be pretty easy to do. We don't really have to worry about getting the bounding box. We can just do a fixed range. So what I can do is kind of do the same thing, create another node called random float in range from stream. But this time, instead of connecting up the min and max, I'll set them. So I'll make the minimum 0.1 the original size, the maximum 0.5 the original size. And we'll use that for our transform scale. And we can split that out and do, we can make them all the same technically for now. And then connect up our seed stream. And if we look at that, compile, okay, now they're different sizes, those boxes. Some are smaller, some are larger. Gives us a more interesting structure now. But the rotations are all the same. So maybe we want to randomize the rotation, but we don't want the rotation just randomized. So some of them are like diagonally rotated. We want them to rotate maybe in increments of 90 degrees. So for that, I'll split out the rotation XYZ. I will take the stream seed, and very much like we've already done here, just more of the same thing, except I'll do a random integer. So not worry about decimals, but whole numbers. So random integer from stream. And won't matter what the minimum is. I'm just going to set the maximum to 4. And we're going to multiply that. It's going to do a random integer from 0 to 4 and multiply that by 90. So it's rotating 90 degrees randomly, either 90 degrees, 180 degrees, or whatever 90 times 1 times 2 times 3 times 4 is. You'll choose a random number from 0 to 4 and then multiply that by 90 degrees. And then that will be our outputted rotation. So I'll do that for X. And we can also do that for Y and Z. And we can have these all different or all connected the same here. Connect that stream seed up, compile, look at it. Okay, so now do they look all the same? Some are rotated, some are not rotated. If we want that broken up a bit more, we could go here and just, maybe I'll copy and paste this. Maybe you'd want some rotating like 180 degrees or different amounts. Or we could do this so that the X, Y, and Z all rotate differently each time. So connecting this all up and compile, save, and there we go. Now they're kind of all randomly rotated. So now we have like an interesting structure, but it's always placing these duplicates the same way. So how do we go about using that seed that we've created here? So very easily, we're just going to go to variables here. We're going to create a new variable. We'll just call it seed. We'll make it a integer. We'll make it visible. We'll place it, compile, give it a default value of 0, connect it up to our seed for our set random stream seed. And it'll pull that value. So now if we compile and save this and we look at our result, here it is. If I change that seed, so I go to the seed value here and I change it to 1 or 2 or 3 or 4 or 5, we're getting all these different, scatterings that are kind of unique. So now we have something that gives us some random breakup, but the numbers will always be the same. Like if I do a seed of 100, it's like that. Seed of 200 is like that. If I go back to seed 100, it always produces that same kind of look. So it's nice because every time you run the game, it's not going to be random. It's going to be randomized based on these seed values, which you can somewhat control. So it's going to make it random, but not totally random, where every time you run the game, it's different. So now that we have this, we could do one last thing. Maybe our original cube size is too big, so we can always scale it down a bit, like half the size. But we probably want it connecting, so maybe 0.75 or something. But you can add more complex code or more complex nodes to your construction script. But I think this is good. We're getting like a fairly kind of randomized shape here. And if I go and change that seed, we get these different shapes. Maybe that original cube could be bigger. Maybe some of these are going too small, kind of being disconnected and floating. So I'll just go back here and change my minimum scale to something like 0.25 and maximum to 0.75, just to make sure there's like a good amount of overlap. So that's okay. So I'll stick with that. Now the next thing is we're going to take this blueprint we're going to use PCG to place a bunch of points and then place this blueprint on each one of those points and randomizing or changing the seed each time it places this blueprint so that you get totally kind of random duplication or scattering of this blueprint. So next, I'll save this blueprint. I'll close this. I'm going to go and create a PCG volume from up here. So PCG volume, and just have it placed somewhere in my scene. I'll zero that out to the center of the scene and make it bigger so it kind of encompasses my work area for now, or a large area. And then what we're going to do is go make a PCG graph. So I'll go down here and create a PCG graph. I'll call that PCG graph something like PCG, maybe greeble scatter. And once we've done that, we'll open up that PCG graph. Here's our PCG graph network, input, output. I can ignore that. I'm just going to create some points. So I'm going to create a points grid, just a grid of points. And on that grid of points, you specify how large it is and the cell size. Maybe you'll bump up the cell size a bit to 125. And we can save that. Probably test it out to make sure it's working, but I'll just jump ahead and spawn an actor, which will be our blueprint. So we'll spawn an actor. What actor are we spawning? Well, I go to the template actor class here, and I can search for my greeble. And there it is, BP greeble. And I'll save that. And let's see if that works. So if I minimize this and we have our PCG volume, I go to that PCG component, and for the graph, I connect the PCG greeble scatter. I can click generate to make sure it generates. And there it is. There's my PCG points, all scattering that blueprint that we made along those points. Now, the problem is they're all using the same seed. Our seed was a default of 0. All these blueprints have that same seed, 0. So that's why they all look the same way. What we want to do is go into our PCG and modify that attribute in our blueprint to a different number each time it places this actor on the points in PCG. So to do that, we're going to go back to our PCG graph. We'll go back to our spawn actor node here. And on our spawn actor node, if we look to the settings here, we have our blueprint that we're using for our actor class, but we have this option up here, which is kind of interesting, for spawned actor property override descriptions. So this, and I'm going to add a new one. And then what we can do is say the input source. What is the thing that we're populating from PCG into what attribute in our blueprint? Well, our blueprint has a property or attribute called seed. So I'm going to set that seed attribute in our blueprint with an attribute from PCG. Now, PCG already has a seed attribute that I can use. I can just click on this plus and I could fetch, position, rotation, or transform, or other things, but I'm going to use the seed attribute. So it's going to take our seed, our random number seed for each point in PCG, and feed that random number seed into our blueprint attribute called seed, giving our blueprint a random scattering each time. And by doing that, I'm controlling our blueprint attribute with a PCG attribute. And by saving that now and taking a look at what that does, now each time it scatters, it's giving us different breakup and different variation. So it feels a lot more unique. Now, even though PCG is fast, don't go crazy and do something like 2500 for the point grid size. Otherwise, you're going to end up with having to wait a while, and it's going to create, a crazy amount of these blueprints. It's created, like in this case, 66,000 copies of that blueprint, which is a little bit excessive. So there are some things you can do to speed it up, and it's not a solution for all problems, but it's something that gives you an idea of how you can now place blueprints with PCG and use PCG to change properties of that blueprint, which can be very useful in a lot of environment or scene building. And again, the more efficient way to do this would also just be to do all that scattering, all that placing of these meshes in PCG, but sometimes it will be useful to just populate some actors or blueprints that you have with PCG with some of your settings varied or changed. So this can be used in combination with PCG. As long as you're not overusing it, it can be beneficial. But if you end up with tens of thousands or hundreds of thousands of blueprints in your scene because you're populating them with PCG, there are other ways where you can mix and match different methods together to get better performance. So just keep that in mind once you do start playing around with this stuff. If you enjoyed this video or you learned something new, don't forget to like and subscribe, and check out the Patreon down in the description below. If you are part of the Patreon, you will get the PDF for this video as well, which goes over all the steps we went over in this video in a little bit more detail.